So welcome to Fayetteville Tech's Cumberland Hall Auditorium. This, if you want to pan out, this is where we put on all of our, not all of, but some of the concerts will be done here, some of the play productions. There are meetings and other things that go on in this space. But it's a fairly big space, 270, give or take, seats, 276, somewhere in there. There is a stage. Stage is like 28 feet by 16 feet deep. Not a big stage, but it is a good stage, and it works well for concerts and those kind of things. So in this space, our main concern is talking about audio at this point. So right here, if you can look up, we have 4 speakers, one on either side of this column. It's hard to see this one because it's in the dark. Let me get the lights real quick. So there's 4 speakers, one on either side of this column, and the same thing on the other side of the stage over here. Same thing, 4 speakers. Now these are powered speakers, so they're powered through electric, not by amps, okay? So if we go back here, you can see those 2 things here that say Shure on either side of the air vents. These are antennas for wireless lapel mics, or technically they're not just lapel mics. We have both handheld mics and lapel mics. There's 8 of them on the same system. So one handheld mic matches one lapel mic. You can't have them both on at the same time because they're at the same frequency, but you can have up to 8 devices intermixed of those. So we're going into the booth. So this is our control room. The control booth. There is a window. Sometimes it's locked, sometimes it's not. You can see the little lights. That's the light board, or the soundboard rather. That's the thing we're going to talk about. This is a controlled space. It is locked 99% of the time. And your instructor may or may not have a key.
I do.
You sure?
Yeah.
You been in here already?
Yeah, I checked it out.
Okay, good. So there is a lot of stuff in this space. It does need to be cleaned because that's typical of things. So here's the thing. This space is used by a lot of people. It's used by the theater department, it's used by the music department, it's used by everybody on campus, it's used by outside organizations. We don't have full access or full control over this space, but we try to keep it as clean as we can, keep it organized. It is our responsibility, but it's anybody's responsibility is using this space. Okay, so here is the sound mixer. As you can see, it's the standard sound mixer. We'll go into some of the details of what all is here. Here you'll see a rack. This is a rack that controls a lot of the sound and or other things that go on in this space. So basically what you'll find over here on the bottom row here, where the red lights are, those are amps. Those are the amps that control all the sound. So if those are off where the red lights, that means it's off. That means no sound is going out into the speakers, period. No matter what we do on the soundboard, we can see a signal coming in. We will not get a signal out as long as those are off. To turn them on, you just literally do this. It's not going to work right because I want it to. Now they're all on, we're good to go. Do you need all of them on to do sound out into the house? No. Technically you only need 4 of them on, but that's okay. We turn them all on because it's easier and better. That way we know we're safe regardless of what happens. So we'll sit down here. So this is a complicated system because this is a digital soundboard, not an analog soundboard. Some of you may be used to analog. That's the style that's been around forever. If you got a portable system, chances are it's analog, okay? It works exactly the same way. It just has a lot more bells and whistles that you may or may not need to know. And we won't go into all those bells and whistles. We're just talking about standard audio, okay? I will say this little device has nothing to do with this, but it does. It's a separate device. So this space was designed so that when somebody comes in and uses it, but they don't need a full system, they just need a microphone and they need to use the projector that's up there, then they can turn this one on and use this to control a microphone and the projector. So this is here. We're getting ready to have it moved over into the rack so it's out of the way because only certain people use it. I'm just going to set it out of the way for now because this is what we want to talk about. So with an audio mixer, whether it's analog or digital, there are certain things that are going to be the same. For one, you're going to have your different channels. This one has 22 channels. As you can see, it's numbered 1 through 22. Technically, there are other channels. We're not going to get into that because you have other types of input. So if you look back here on the back of the board, you'll see all these little places to plug in microphones. These will have XLR, which is a balanced audio, as well as, if I'm not mistaken, no, actually this one doesn't. I don't think it has it at all. So what you'll find on a lot of the analog systems is you'll find for each channel that has XLR, a balanced mic input, they'll have a 1/4 inch unbalanced microphone input. This one does not. This one has, some of these are inputs, some of these are outputs. So the advantage to a digital board over an analog board, besides all the extra bells and whistles that you won't use, is you can put subgroups out as well as other outputs more than you can through an analog board. So what you see here is, even though there's a bunch of microphone inputs here, you'll see that underneath it there's a lot of XLR outputs. Those are going to subgroups and or to other channels, out channels, not input channels. So in other words, some of these, like these, should go out to the main subs, meaning not main subs, main amps. So they go from here, the cable runs around somewhere to the rack, to the amps, so that they go out, okay? Some of them are going through output outs, and as you can see, some of these are not being used, so that means there's only so many outputs. They start over here somewhere. So these sub outs, so what we've got, this is where it gets complicated. We have outputs that will get programmed in when we do this to go out to here, and in this rack, you didn't see it a minute ago, but in this rack we have a Tascam digital recorder. So the idea is anything that's coming into the board can be programmed to go out into the Tascam. So it uses an SD card and it records an MP3 file basically, or a WAV file depending on how it's set. So that anything coming in, so if we're doing a concert on stage and we've got sound balanced into here, now this is where it gets complicated on a concert. So if they're using amps, their own amps on the instruments, on the guitars or whatever, keyboards, it doesn't matter. If they're using amps there and those amps are not plugged into the sound here, then we're relying on the microphones to pick up a balance. So that's where somebody like you that's learning this needs to be able to find a balance between the inputs of the singers, if there are singers on that concert, and the balance of the audio for the instruments. And again, if one guitar has got their amp way higher than another, it changes a lot of different things. But once you balance it into this system and whatever's coming in here, it goes into the Tascam. We can record the entire concert, and what it does, if it's too big of a file, it'll just keep recording into multiple files. So it's a continuous thing so that you don't lose anything, okay? And then you've got a good quality sound for things. So I've done this for a play reading. We did a reading of the play Importance of Being Earnest, where I put microphones on stage, balanced, and set them different. So with microphones, you don't want microphones right up against each other. You want a little bit of space so that they don't get interference because the frequencies are close. So what I did is I gave them space throughout the stage. There was only maybe 10 actors, so no more than 10 mics. And I didn't just use lapel mics. I used not lapel mics, but handheld mics. I used plug-in mics as well, not wireless, but plug-in, both. And again, it balanced out so that I can record everything and then later go in and edit out all the mistakes that the actors made, because they do that. Okay. So anyway, this is the sound mixer. It's already on. Ours we keep on 24/7, and the reason for that is, one, it's not always, so there's a debate. It's either good to keep it on all the time or there's not. Here's the difference. If you keep it on all the time, it's that much time that's being on. It's not being used, but it is on, so it's technically used. If you turn it on and off, then you've got the wear and tear of turning it on and off. So it's either or. Since we use this all the time, somebody's in here almost every day probably using this to some degree, except for on weekends, on certain weekends. So since it's being used all the time, and because it's digital, it is connected to a router somewhere over here, wherever they put it, that connects to the internet to constantly update the firmware and drivers and such, so that it stays up to date all the time. Which again is another debatable thing, whether you keep it up to date or wait until the firmware has been processed right. Okay, enough of that. So you get here, there is a power switch back here. It's all the way, it's a toggle on and off switch at the very bottom underneath everything. That's the main power switch. I'm not going to turn it off because it's already on. It'll take a moment for it to boot up. Keep in mind, on a digital board, unlike an analog board, it does take a little bit longer for the computer processor to boot up and be ready. An analog board, as soon as you turn it on, it should be more or less ready to go. On this one, you have to wait for this thing to boot up and go through its process. I'd say within 30 seconds to a minute max, okay? Unless there's an error issue, which if there's an error issue, you got other issues, okay? There is another power switch here. So just turning one or the other off does not necessarily kill the board, but both of them would. So once you get it turned on, now you've got everything you need ready to go, right? Check your amps over here, turn those on. We did that a minute ago, so we know they're on. Then the first thing you're going to look at is your inputs and your outputs. So we've got 22 inputs. Our main concern for outputs are our main speaker cluster, which is out there, and that is one of these two, if not both of these. Depending on your board, it'll either say L and R or it'll say LR. This one, it's L and R. This is our left, right, out. That's our main speakers. This mono select is for internal recording and or monitoring. For our purposes, it's monitoring. Okay. I didn't show it to you, but over the stage there are 3 hanging choir mics. They're not for any purpose other than for us to hear in the booth. So we have speakers set up somewhere, wherever they keep getting moved because they're portable speakers, these kind of thing. So it's set up so there's a headphone jack somewhere, I think it's over here, for headphones. So what we do is we plug these speakers in, and then we can monitor in the booth, shut the window, and hear everything that's going through those 3 microphones. Okay, and those 3 microphones are plugged in right here. It says PPN 1, 2, and 3. Okay, or it's actually these 3. And you can see that as I'm speaking, you can see slightly that it's going up and down. Can you see the little green light kind of moving up and down? And those aren't even turned on. So if I turn them on and I bring up some volume, then anything that's going out on that stage we'll be able to hear through these speakers if they're plugged in, which currently they don't seem to be plugged in. Okay? So you've got your inputs, you've got these. This will need to be brought up. The best case scenario, when you set up sound, if you've never had it set up before, if you're setting up the board, start everything at 0. That's 0 decibels. Okay? don't think of it higher and lower. It's higher and lower decibels, not higher volume, lower volume. It's decibels, okay? That's something that a lot of people get confused. So I always say start everything at 0. Now you don't want your inputs to start at 0 yet, because there's a reason for that. But your main out, this is your main balance, right? Everything comes through here, you want it to balance out. So the reason why you have inputs, different input channels, is if I have 5 mics on stage, each one of those mics are equal, theoretically. Yes, if they're the same exact mic set up exactly the same, they should be equal. The voices or the instruments or whatever's coming through them are not equal. Just like a guitar may or may not be loud. If it's an acoustic guitar, it's going to be as loud as you strum it, right? If it's a drums, are drums louder than a guitar? Oftentimes. Again, depending on which part of the drum set they're using, right? Piano is going to blow everybody out if it's somebody that's really hitting the keys, okay? But if you got a vocal, if you got 2 vocal people, higher voice is not going to be as loud as a lower voice, typically, depending on, when I say lower voice, I'm talking about in the tenor range, tenor, soprano. The soprano, if they're hitting the really high notes, is either going to be really soft or really hard. Same thing with the tenor. But when you get into the bass notes, those are real low, and it's harder to hear low voices, right? So you need to bump those a little higher, and that's why you have different inputs so that you can adjust. And so when you bring up if these 2 are vocals, which it says here, then when you bring them up, if you start at 0, they're not necessarily equal. But if you move one of them up, now that one's going to get a little higher. That's going to be a little more volume coming in, which gives us more options for equalizing the sound. So we adjust these as we need. And basically the way you have them adjusted is have them hit the lowest notes they hit and the loudest notes they hit. Okay, for whoever's doing it, whether it's a guitar, whether it's a person, doesn't matter. Hit the low notes, the loud notes, and if they can maintain it for a moment, that's great. If they can't, just keep having them do it over and over again, okay? So you always do a sound check before you do anything else. And this is what you're doing, is adjusting everything. Now, once it's adjusted, is it adjusted correctly for the concert? Never. You're never going to get a perfect sound setup. You're going to get as close as you can possibly get without any problems. Now here's where the digital board comes in handy, because you have these things here called a gate and a compressor and an equalizer. You may have an equalizer on an analog board. That's just basically the same thing you would see in a car stereo or a home stereo, where you can adjust certain things. In a digital board, you've got a gate and a compressor. So I can take any one input, and each input I can adjust the gate and the compression. So if I've got 2 singers and I've got one that just really belts everything really loud and it's starting to squelch out on here, and if I can't bring it down enough here to cause it to stop, I may lose volume and not be able to hear them, but it's still squelching the system. In other words, it's putting a red light on this, okay? We don't want that, because then we're getting distorted sound no matter what happens. So I can use this gate and the compression to compress that down, so that no matter how loud they get on the highest or lowest notes they are, it'll never squelch it out. It'll compress that sound so that no matter what, it never sounds distorted. The cool thing about it is when you do that, you also are eliminating background noise that could interfere with. Does that make sense? So that, like, oftentimes you'll hear on a church, when they're doing church service, you'll hear babies crying in the background, and it just sounds like that's so loud. Well, imagine if you were right there next to the baby, right? But when the pastor or whoever's speaking or singing or whatever's going on at the time, if you set the compression and the gate, you'll hardly ever hear. You may still hear it, but you won't hear much of that sound. You won't hear a lot of coughing or sneezing or other things going on either, because it's, one, if the mic is set up for that person in front of that, so like I'm wearing this mic is picking me up primarily. You'll probably hear this background ambiance sound of the air conditioner and other things going on, but it's compressed a little bit because this is designed to pick straight up, right? Same thing with concert. The microphone, unless they're using omnidirectional, which is designed to pick all around, if they're using unidirectional mics, it's picking up directly ahead of the mic. Got it? So that's what you're looking at. So you're already compressing some sound just through the microphone placement, which is extremely important, and your instructor is going to talk about placement later. But once you've placed the mics, you've got the people or the instruments or whatever's going on with the mics arranged, you start bringing inputs, you start adjusting the levels of the inputs so that they're equal based on the quality of sound that you want. Now, when I say equal, that does not mean everybody's of equal volume, equal sound. That means the mix is the way that either the music director or whoever is in charge wants it to sound. If that means squelching, making one person way lower volume than others because we only want to hear their volume on certain notes like the hard notes or high notes, then that's the way it's designed. Again, that's up to whoever is musically in charge of whatever sound, in charge of the sound. Okay. Normally you would just assume everybody's going to be at a similar volume level going out. Does not mean coming in at the same volume level. Okay. So once you've adjusted these, you have to turn them on. Now on an analog board, you may not have an on and off switch. That's up to how that's designed. It may be once it's plugged in, it's automatically on. Okay, but on this board, a digital board, you're going to turn it on. Okay, you do not have to select. The select is for this mono select here. That's for us in the booth. Okay, and if you don't set it up correctly, like when we have these set up, if I have these turned on, if I turn all three of these on at once, I say I can't select them all at once because it won't let me. You can only select the one. And the selection is also for, if you're ready, for setting all your different components. So if you look here at the gate and the compression and equalizer, it's selected for channel 1. Now if I push channel 2, notice how the lights change differently? Because it's showing us the difference between the two different microphones. These are the exact same mics, but you notice the settings are different because somebody went through and set them to different things. You also notice this output where there's a delay here. Mic 2 has a delay, whereas mic 1 does not. Not sure why that is, because it shouldn't. In our space, we don't really need a delay. If you're doing a recording, sometimes you'll put a delay just for sake of editing purposes or something later, especially if it's like a live stream, but we're not doing that. And then as I go to each one, you notice that each one changes based on whatever was set last. Okay. And again, like I said, we are not the only ones that use this board, so other people come in. In theory, they're not supposed to use the board without somebody like music or theater person or media people involved. They should only be using this system without that. Okay. So that's that. So the solo does again allow you to listen to in here, but you can only, depending on how it's programmed, like I said, if I do these three here, I select those, I'm not going to hear anything. But if I only select one, I can hear it through the system, through our speakers. That can be adjusted. That means going through here and programming some stuff, which we don't really want to do at this point. Because as long as I can hear one, I don't need to hear everything for most purposes. Okay. So once I've selected this microphone and I've got it set. So like I said earlier, you don't want to start it at 0. The reason you don't want to start it at 0 is you don't know what the gain is set at until you've turned it on. So if you start it down here at 00, which is infinity actually, it looks like it's 00, but it's infinity. That means absolutely no decibels are going through. They're coming in, but they're not going out anywhere. Okay, and as I slowly raise this up, I'll hear whether this gain needs adjusted. And always assume that the first time you pick up a mic, whether you've used it the day before or not, always assume that the gain may be off. Because if I was to start this at here and that gain is set way too high, I'm blowing speakers or I'm blowing amps. Blowing a speaker is one thing that's easier fixed than blowing an amp. Okay, amps are expensive. You don't want to blow an amp because you blow an amp, you have nothing. Speaker, you might be able to get a replacement speaker fairly quick. Okay, so always start low and slowly move it up, and making sure that if it's a mic set on stage for a singer, that person's up there talking or singing, so that we can hear whether sound's coming in. And you'll know whether sound's coming in because this will light up. So if I was to get one of these mics, so here is one of the handheld mics that's on these. This is actually one. Let's imagine they put the right one in the right case. Okay, so you turn it on, you have your mode, you have your set. Okay, so it shows you that it's in group 1, channel 2. Now, without even anything going on, I'm going to tap the mic. Okay, up here is the transmitter. So this is the transmitter, here's the receivers in the top of the rack. So if I tap the mic, I should see lights bounce up and down on that receiver. Do you see it on the first receiver, top left?
Yeah.
So that means that this is programmed and put in the group and channel for that receiver, which is 1, which is the one we wanted. So now it's on. Notice this mic does not have a mute button. There's nothing on here that says mute. It's not designed for that. The mute is here on the board. Certain mics, whether it's a handheld or whether it's an on and off, even the mics that you plug in through XLR, some of them have mute, some of them do not. Be aware which ones do, because it's important that you may have to be the one to mute it. In theory, whoever's on the board should be muting. Nobody should be muting things out there, because what happens is if an actor or a musician is out there and they turn the mute off, or they turn it on mute because they finished their song, it stays on mute. And then the next person comes out thinking it's alive, and you don't hear them singing until somebody says, "Hey, you're on mute," right? And we're back here at the board going, "You're on mute. I can't do anything." They can't hear us because it's too loud from everybody else, and we're not trying to be loud because we don't want the audience to know that, right? So that's the case. Always assume that whoever's on the board should handle the mute of the mics. Okay, that may be difficult. I've been in a show where I had 22 body mics, 22. And I made sure that we were the ones that controlled who muted or not muted, okay? So it's on, it's live, I've got sound coming in. If you look here on this, where it says WL1, you can see that as I tap, it makes noise. If I tap too loud, see how it gets that orange light? And if I go really loud, it goes into a red light. That is what we call too much input, squelching, whatever you want to call it. So again, if this was up here and I did that, there would be some major problems. Now, since I don't have this turned on, the speakers are not a problem. It's the amps that are a problem. Okay? Now, in theory, it shouldn't even go to the amps. But it all depends. You always assume that no matter what you do, sound is going out until you don't assume that no sound will ever go out until you turn things on, because you never know how things are wired in if you didn't do it yourself. Okay, so even though this is up, you know the sound's not going out because there's nothing going out there. If I turn this on, sound's still not going out through this mic because I got it down here. But if I bring it up, you can hear the sound out there now. So I don't want to go too loud with this, or I'm going to start squelching this out. Testing. So even right here, I'm almost at 0, and I'm talking pretty good. I'm not squelching this out because this one's been set up fairly decent for what we're doing right here. Testing. So if I yell, I can get it, go. I can get it briefly to that red. We don't want it way up on the red, and we don't want it to stay on the red. Okay, and sometimes when you're doing like a guitar, or if you got keyboards going in, and once it gets into that squelch range, it picks that up and amplifies it and keeps it going, and then you just hear that, and that's where you end up with a lot. We call it feedback, but you're ending up with a lot of bad sound that potentially will blow the amps and the speakers. So don't do it. Okay, so since I'm here, I just want my person to talk, and as you can hear, there's nothing going on. I don't know if the sound will pick that up, but eventually it will. So as I slowly move up, and I'm still speaking into the mic, I can see that more volume is coming in here because it's getting more green lights. I can start to hear it in the sound out there. So now I'm at 0, and I'm just talking in a regular voice. I'm not talking real loud. And again, notice here, it pointed to me. Notice here, as I move the camera or the microphone closer, the sound gets more loud as we go. And again, that's the way this is a Unicom. This microphone is designed to pick up almost directly ahead, not all around. So if I speak from here, and your instructor will tell you the appropriate distance, it's usually 6 to 8 inches, give or take. So a singer should not be this close, any closer than this to the mic most of the time. Okay, so right now you can barely hear me coming out there, so I probably need to bump the volume up. Notice it's still not great. I mean, from what I can hear in here, I can hear it. I need somebody out in the house out there to listen, because it may sound like, oh, it's about right. Out there it may be way too loud, okay, or it may not be loud enough. It sounds like it's probably, based on my experience in here, because I've been using this space for 18 years, so I have a good idea for it. It sounds about right, maybe just a little hot, which means I would bring it down some. And this is just me speaking at regular volume. If I start getting loud or getting into high notes, which I'm not going to do because I don't want to blow your ears, then this is going to be even hotter, which means bringing it down some, or going up there and setting those things. Okay, so that's the thing you want to do. So what you'll see is experienced singers will sometimes come in closer when they need, especially if they've got like a bass voice or a lower voice. As they get into the deeper sounds, they come in closer, because again, deeper sounds don't transfer, they don't go across the air as easily and smoothly as others. And it's just like heat rises, volume rises, sound rises. So as it comes out, a low sound goes lower. It's almost like that. It's like this goes low, a bass sound would go low, tenor or baritone will kind of be about here, and then soprano starts to go up here, right? Mezzo soprano, I mean, it's almost like, right? That's not true, but that's almost the way to look at it in some ways, because it really is. Especially when you're talking about volume, right? The number of decibels that are coming out. So anyway, this mic is more or less set for what I need to do for this purpose. And again, this will probably be on a mic stand out there. With this kind of mic, or even with the wired mics, you might have a singer moving it around. The only thing is, if they're moving around on stage and they're holding the mic, if they don't hold a wireless mic correctly, because here's where the battery is, if they hold it here, which seems like a good place, sometimes that can cause that battery to shake a little bit and you lose signal. If you hold it too close up here, you're probably causing problems with the signal as well. Does that make sense? So you want to be here, but you don't want to be on the buttons, because you don't want to accidentally hit buttons. You want it to be, so unless there's a need for them to hold it, just put it on a mic stand. Now if they're dancing around, if they're dancing, guess what? While they're dancing, chances are they're not singing. They don't need to hold it. Besides that, that's why lapel mics were designed, so that they can wear it and not be touching it and worrying about it losing signal or doing anything. Okay? So over here we've got this mic set. We've set our speakers up to be on and off. So now we've got sound. Now here's the thing. If any one of these things is not set right, we don't get sound. So if I turn this off, we don't get sound out to the house. I can talk all I want. I can get a signal in, but nothing's going out because I turned it off here. So I turned it back on. Same thing here. If this is all the way down, no sound's going out to the house. It's just, but I'm still getting signal in because this channel and these signals here, everything here is about input and adjusting that input to go out, okay? Same thing here. I've got sound going out, but if I turn this off, there's no sound going out because the speakers are basically turned off, which means the amps, even though the amps are on, there's no signal going to the amps to go out to the speakers. So now it's up, but if I turn this down, again, no sound goes out. Always, like I said before, always start at 0, work your way up to 0 here, and then adjust based on that, okay? So now I seem to sound a little hotter than I did before. Now, the last thing I want to talk to you about for sure is this. Whether it's a digital board or whether it's an analog board, does not matter. You are going to have a balance. This is the left and right, okay? So notice it's slightly to the right. I don't know why. These matter, but they don't matter. They only matter if you're doing either surround sound or you're doing left-right speakers. Our signal goes to both speakers equally. So whether I have this on left or right doesn't matter. In other words, we're not necessarily going out in stereo, we're going out in mono in a way. It's kind of like that, okay? So, but if you're doing stereo, you want the left and the right to be balanced, which means halfway up. So halfway lit up, okay? When you select it, now you're looking up here. There are things, whether you've got a mic, again, whether it's analog or digital, doesn't matter. You've got certain things. So you've got this where it says gain trim. First, you get this 48V and this not to do thing. This is talking about whether it's phantom powered or not. That's going to be based on the type of microphone you're using. Some lapel mics will be phantom powered, some will not. Some powered plug-in mics, XLR, will be phantom or not. It should tell you on the mic whether it's phantom or not. If you bring this all the way up here and you still don't get any volume, there's a chance that it's phantom powered. If that's the case, bring this all the way back down, push the 48V, and then slowly bring it up until you get volume, because the volume level is going to be with a whole different decibel level than before, okay? Most of the time you won't have to deal with that unless you've got a specific microphone that requires phantom power, okay? So that's what those two are. This gain trim, this is the gain trim. This is where if it's starting to get over here and it's starting to get into the orange or red, I can adjust the gain, which adjusts the high, mid, and low all at one time to go either left or right. Left should bring it down, right should go increase it. So if you're not getting enough volume and you're all the way up, you can go to the left or turn clockwise and it should increase the gain, and it does have numbers here. On some boards it'll be digital numbers, but basically the higher the number, the more gain is going through, which means the more volume we're releasing from the input into the output, okay? So again, start low, don't do that before you get too high. Oftentimes if it's going into the orange or red here, all you gotta do is bring your gain down, going counterclockwise until it sounds about where you want it, okay? And then always write down your marks. So if this is at 0 and my gain is setting at 20, it looks like here, don't know, 25, give or take, 26, whatever that is. So at 26, then I would probably want to make note of that. So I would say mic 1, channel 1, 0 decibels, balanced, gain is at 26. Because I may have to reset that. Maybe somebody accidentally bumps it. Maybe somebody comes in and changes it thinking it needs something else. I would want to know that when I come in to do a sound check, that if I've already done this the day before, because oftentimes concerts will set up the sound the day before, And then the day of the concert, you don't want to just come in and just start playing. You want to come in and make sure that everything's set the way you left it. Again, digital board, all this information is digitally set by the board. If the computer crashes or gets rebooted or the firmware updates and it clears the system for whatever reason, you starting from scratch. Therefore, you've got to come in and know what each one of these settings were so that you can just boom, boom, boom. So if I already know going in that this is at 0 decibel, I just bring it up to 0. I make sure that's balanced. I bring it up to 26. More or less, I should be good to go, as long as this is also where you need it. Does that make sense? Because what happens is if I turn this board off, no matter what I've got up here, if all these are turned on, they all go down to 0 and stay there until the board comes back on. And in theory, it remembers where it was left off. But again, if there's something that crashes the board for some reason, all of these stay at 0. It may light up and may be working perfectly fine, but all your data has been erased. Therefore, you need a backup. Okay? However you back it up, whether it's on paper, whether it's on a phone or a tablet, doesn't matter. Just have it. Okay? And you do that for every single microphone that you need. You also do it for this. Make sure this volume's where you need it. And if you're doing any subs out to those, make sure they're where you need it, okay? On some boards, you will also have a high, mid, and a low. Is that on this one? I think it's on this one. So on the equalizer, that's your high. This is your mid, high, mid. So this one actually has 4. So your high, high, mid, and low, mid. Theoretically, there should be 3. High, mid, and low. This is for high sound, low sound. So if your mic is making a squealing sound, if it sounds high-pitched, adjust the high. If it sounds like it's a mid-level pitch, adjust the mid. If it's a bass level or low rumble, adjust the low. That's as simple as you can put it. It requires you to have kind of an ear for what the sound is, but that's something you'll develop over time. So those are the 3 things that you would adjust. And then this is just an extra thing for the equalizer. It doesn't really matter. And then these adjust frequency a little bit. Again, not a whole lot. It's just, this again has a whole lot of bells and whistles that we don't use because for what we're doing, we don't need it. It's not to say that we wouldn't do a concert at some point and adjust some of these things for the sake of we want it to really sound great, because the more you know about this stuff, the more you can really play with sound. That's the easiest way of saying it. Okay? That should be most of what you need to know, at least to start with. Probably more than you wanted to know, but that's it.
Yep.
If you have any questions, ask your instructor.
Yep.
Or you can get a hold of me. I'll tell you too. All right, sounds good.
Good.